So today, 12, you guys paying attention? 12, 4, 17. Common Core Standard, we're going to do our right triangle trig. We'll go trigonometric. Trigonometric. I just say trig. Trigonometric ratios, okay? Trigonometric. I think I got it right. Trigonometric, trig, just trig, okay? From now on, I'm just going to call it trig, okay? It's a trigonometric. Whew, that's a mouthful, huh? Anyway, so here's what we want to write. So from a right triangle, let me go ahead and draw a right triangle. Okay, so draw a right triangle. Has to be a right triangle, okay? And we're going to put a little symbol here. Okay, and this little symbol, Madison, Shayla, here we go. This little symbol here, the symbol we call theta, but it's just a fancy Greek letter. For us, it means angle, okay? So when you see this symbol, it's the angle, all right? When you see that symbol, in fact, if you look up here on the board, you see the sine, cosine, tangent, theta. Theta means the angle, okay? So if this is my angle, we need to get those words up there. So from the angle, watch real carefully. We know this side is directly opposite. So this is my opposite side. From this angle, this would have to be my adjacent side because it's next to it. And of course, the longest side in a right triangle is always the hypotenuse. Okay. So when we do these ratios, a ratio is just a fraction. Okay, a ratio is just a fraction. So if I do the sine function is going to be equal to the opposite side over the hypotenuse. Okay. So we're going to put numbers in there eventually, but that is the definition of sine. The cosine function is going to be the adjacent side over the hypotenuse. And I'm going to shortcut these. I'll call it the adj for adjacent and hyp for hypotenuse. I don't want to write the whole thing out because I'll probably misspell it, and so it's just easier. The tangent function is going to equal the opposite side over my adjacent side. Now, it's a little tricky. I didn't make this up, okay? But, hi Landon. But the cosecant does not go with cosine. The cosecant is the opposite of the sine. So instead of that being opposite hypotenuse, the cosecant becomes the hypotenuse over the opposite. Okay? And the secant function is the opposite of the cosine. These two are opposites. And instead of being the adjacent of the hypotenuse, the secant just becomes the hypotenuse over the adjacent. And then finally, no surprise, the cotangent is going to have to be the opposite of the tangent, right? That makes sense, right? Tangent, cotangent. So the cotangent function is going to be the opposite tangent, which goes to be the adjacent side. Blue Cross. Here. I don't know, I'm teaching. Adjacent over the opposite. Okay, now, everybody have that. And I'll whisk it away in a minute. And we're going to look at, or no, it's, yeah, Brooks.
Are those used for solving triangles at all? Or are they just
you rarely use these three, Brooks. I mean, rarely. Rarely, rarely, rarely. But in math, if there's a way to express something, we will, right? Yeah. Okay. Okay, whisk this way. Everybody got it? Everybody good? Okay, thank you. Okay, so let's take a look. Common Core. We're going to be taking a look today at right triangle, trig. Can I go trig? Trig. Ratios. Okay. Now, so everything starts with the angle. Everything starts from the angle. And never use the 90. Never, ever, ever use 90. Never, ever, 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 ever use the 90 degree. Don't ever use 90. So A or B. We're going to use A or B, and it doesn't matter to me. Caius, which angle do you like? A or B? It doesn't matter. A. A it is. So by picking A, guess what? You've forced this side to be the opposite, haven't you? And that side to be the adjacent. Now if you pick B, guess what? Does that make sense? Okay, but he picked A, so that forces that one to be the opposite, and that's the adjacent. Makes sense? So let's figure out the sine. So the sine of A. Well, take a look at your notes. Sine of A, sine is the opposite over the hypotenuse, so it's going to be the 15 over 39. That's it. So the sine function, if you want, it's up there too. It's the opposite side, which is the 15, over the hypotenuse, which is 39. Okay, let's do cosine. Cosine of A. Cosine would be what? The adjacent, which is my 36, over my hypotenuse, which is 39. Okay? So if I label these, that helps. That's my opposite, that's my adjacent, and that's my hypotenuse. Oh, I can't see, Dave. Right? Thank you. I'm blind. Yeah. Tangent. Thank you. Tangent A. Well, tangent's got to be the opposite over the adjacent. Again, those are all in our notes, and they're also up there, right? Opposite adjacent. So it would be the 15 over 36. How am I doing? Thumbs up so far? Okay, now, the cosecant of A is the opposite of the sine. So it's just going to be 39 over 15. And the secant of an angle, secant's the opposite of the cosine, so it's going to be 39 over 36. You guys remember doing this in geometry? No? Okay. That's right. Cotangent is the opposite of tangent. So that's really easy. Instead of 15 over 36, it's just going to be 36 over 15. Okay, those are the ratios. Okay, those are the ratios. And we haven't done much with the ratios yet, but we will. Okay? All right. Example 2. Find the sine, cosine, and tangent from these two sides of the right triangle. Okay? So check it out. What do we know? About a 45, 45, right? What's 45, 45? Take a look at it. 45, 45. I think this x squared is 2, okay? So if I wanted to the sine of 45, let's see. Hey, they're both 45, so it doesn't really matter which one we pick, right? Isol, top one, bottom one. Which one do you like? Top, bottom. Pick an angle. Top it is. There we go. Boom. Okay. Top it is. So sine is the opposite, right? Opposite would be the x over the hypotenuse, right? Hunter's going, yeah, I know this, right? We learned this last year, didn't we? So if I have x over x squared to 2, I could probably do a little algebra and cancel the x's, couldn't I? I could. Could I cancel the x's? Heck yeah. So if I cancel the x's, I'm left with a 1 over the square root of 2, right? And that's okay. We should fix that. It should be really the square root of 2 over the square root of 2, right? That is the sine of 45 degrees without a calculator. Wow. Square root of 2 over 2, okay? How about the cosine of 45? Well, the cosine's the adjacent, right? The adjacent over the hypotenuse, so that's going to be x over x squared to 2. Hey, didn't we just do that one? We just did that, didn't we? And what did we get? Square root of 2 over 2, right? And the tangent of 45. Let's see, tangent 45 is going to be the opposite over the adjacent. X over x, what's that equal? 1, right? Okay. All right, I got to do the 30, 60, 90 on, I'm running out of room, forgive me, okay? I'll wait for you, okay? All right, I'm running out of room, so I'll put this on a separate sheet of paper when you're all ready, okay? So, all right, I'm writing it. So here's what I know. I know that the sine of 45 degrees is equal to square root of 2 over 2. I know the cosine of 45 degrees is square root of 2 over 2. And I know the tangent of 45 degrees is 1, right? And if that's true, my calculator should verify it, right? So if I do, like, believe it or not, if I do the tangent, check it out. If I do the tangent of 45, guess what I'll get? I already know. I know 1. It's got to be 1. Boom. I can do trigonometry without a calculator. I'm so smart. Now, what about the other? What about if I put this triangle back up, okay? Here's my 30, my 60, and my 90, okay? Pretty sloppy. There it is. Very sloppy, sorry. Okay, I'm going to use that triangle, okay? You guys okay with that triangle? X, 2x, x squared is 3, okay? Let's see if we can do this, okay? Karina, pick an angle, 30 or 60? 30 it is, okay? You guys like that top angle, don't you? Okay? So, you know what you forced now? Here's what you forced us to do. That has to be my opposite, right? And that's my adjacent. If you pick the 60, then that'd be my opposite. And that'd be my adjacent, right? But she picked the 30, so let's find out what is the sine of 30. What is sine? Check up there. What does sine stand for? What's sine? What's sine? Look up there. X over 2x. X over 2x. And if I simplify the x's, I get 1/2. So you mean sine of 30 will give me 1/2? Wow. I can do trig without a calculator. We're so smart. How about cosine of 30? What's cosine of 30 going to be? Cosine of 30. What do you think that's going to be? Cosine of 30. Think about it. X squared to 3 over 2x. What happens to the x's? So you get square root of 3 over 2. Hey, that's pretty cool, isn't it? And what about tangent of 30? What about tangent of 30? Tangent of 30, hello. Tangent, what's tangent say? What's tangent say? Tangent's the opposite over, so it's going to be x over x squared to 3. If I cancel the x's, I get 1 over the square root of 3, but if I fix it, I get the square root of 3 over 3. I got one more thing to do, and then I'm done. How's that for a deal, huh? One more thing to do, and I'm done, promise. Let's do the other angle. This time, let's pick the 60, okay? So if I pick the 60, then this side's my opposite, right? If I pick the 60, that's my adjacent, right? So my answers are going to be very similar, but let's check it out. Okay, what's the sine of 60 degrees, okay? Sine is opposite over hypotenuse, right? X squared 3 over 2x. If I cancel my x's, what do I get? Square root of 3 over 2. What's the cosine of 60? Well, let's see. Cosine's adjacent over hypotenuse, right? So it'd be x over 2x. But what's that make? Cancel the x's. What do we get? 1/2. And finally, tangent of 60. What's tangent of 60? Well, it's got to be opposite over adjacent, right? It's going to equal x squared 3 over x, which just becomes a square root of 3. Okay. Does anybody see anything unusual? Any patterns? Anybody see any patterns for the fun of it? Anybody see any patterns? Brooks, what do you see? Do you see some patterns?
A lot of them are almost the same as each other.
I might even say, you ready for this? Can I blow your mind? I might say the sine of this angle is always equal to the cosine of that angle. Or I might say something crazy like the sine of this angle might be equal to the cosine of this angle. And that will always happen. Always. Okay, that's all she wrote for today.